All right, this tutorial is on the Big Ideas Geometry section 4.2 titled Reflections. So continuing on the translations that we talked about last section, we're going to talk about how to reflect something, how to identify lines of symmetry, and being able to use those to solve real-life problems. So a reflection is a transformation that uses a line like a mirror to reflect a figure. So that mirror line is called the line of reflection. So in this diagram down below, this line M is considered your line of reflection. And similar to translations, when we had our pre-image that doesn't have any of the dashes, and your image that does have the dash, you're starting with the pre-image of the blue, and you are reflecting across this line of reflection M to get your image P prime. Now, one thing to know about the difference between your pre-image and your image is that they must be the same distance from your line of reflection to that point. So that's why you see these dash marks to indicate that they are congruent. And the line from your pre-image to your new image must be perpendicular through that line of reflection. If your point that you're trying to reflect is already on the image, then or is already on your line of reflection, then your image is also the exact same thing. Since there is no distance from the point to the line of reflection, that point just stays on the line as it's being reflected. So let's look at this when we are graphing a shape on a coordinate grid and what its new image would look like after it's being reflected. So we're going to graph point ABC, the triangle, and then reflect it across the line x equals 3. So moving up our coordinate grid, graphing points A, B, and C should look like that. And then we're going to draw the line of reflection x equals 3. It's on the x-axis of 3, and it's a vertical line. So you're going to reflect each point individually to that line of reflection. So point A is 2 units to the left of that line of reflection. So when you reflect it, you're going to continue past that line and count 2 units to the right to get our new coordinate point A for the image. Notice how they're the same distance away, they're congruent, and those lines are perpendicular to your line of reflection. We're going to do the same thing with coordinate point B. It is 2 units away from our line of reflection. So reflecting it over to the other side, you're going to continue 2 more units over to the left to get your new image B. Same thing with our C. C is 1 unit away from the line of reflection, so you're going to count past that line in the same direction, 1 more unit to get your new C. Then we just connect those dots to create our new triangle. So sometimes you may have points that start on different sides of the line of reflection. When you're reflecting an image, you just count each individual point, how far away it is from your line of reflection. So now if this line is y equals 1, we're again going to graph the same triangle that we started with, ABC. But this time the y equals 1 is a horizontal line through the y equals 1 axis. We're going to still do the exact same thing. We're going to take each individual point, count how many units away it is from the line of reflection, and then count past that in the same direction. So A is 2 units away. We're going to count 2 more units, and there's our new A image. B is 1 unit away, so we're going to count 1 more unit past, and there's our new B. C is already on the line, so C is going to stay on that line of reflection as our new C image. Connect those points, and that is the reflected image ABC over the line y equals 1. Now, using lines over the reflection of y equals x, we're going to graph that line segment FG. And then the line y equals x is this diagonal line with a slope of 1, because the m is 1 in front of your x. So we are going to be reflecting this line segment across that y equals x with a slope of 1. So since the segment from F to its image needs to be perpendicular to that line, we're going to need to find the perpendicular slope of y equals 1x. Remember, the perpendicular slope is opposite and reciprocal. So 1 over 1, the opposite reciprocal is -1. So we're going to use the slope of -1 from our coordinate point F, count that number of distance. So we're going across 1 box and a half box and a 1 in the same direction to get our new image F. You could see it as right 1.5 and down 1.5 as well. As long as you're counting the same distance to the line and then the same distance through the line. Then we're going to do the same thing with our G. So G, we're going to use the exact same slope of -1, count to the line and then through the line. So from G, it looks like it moves a half unit to the right and half unit down. So we're going to do the same thing, half unit to the right, half unit down, to get our new image of G. And make sure after you get both of those coordinate points that you draw those together, because FG is a line segment, so we are reflecting that line segment over the line y equals x. So now using the same endpoints, f and g, over the line y equals -x, which is the slope of -1. We're going to graph that image by flipping our y and x coordinate and changing the symbols, so from positive to negative. So you're going to take your coordinate points, flip your 1 and your 2, and then change the signs. So instead of a +2, it becomes negative, and instead of a -1, it becomes positive. Then same thing with our G coordinate. We're going to change the order and then change the sign. So from 1 to 2, it becomes -2, -1. And you can check that by using the graph. So here's our y equals -x line of reflection, our FG line segment. Count to the line, through the line, there's our new F. Same thing with G, count to the line, through the line, there's your new G. Now, looking at just lines of symmetry in each individual shape. So a line of symmetry is something that cuts an image in half so that you have the exact same thing on the left and on the right. If you think about the human body, you have a line of symmetry that cuts right through vertically, down from your head, through the rest of your body. So we're going to try and create lines of symmetry throughout this hexagon so that we have the exact same thing on both sides of that line. If you draw a vertical line, the whole left side of this hexagon is equal to the whole right side. It is being reflected. Same thing with drawing a horizontal line. Everything on top of this hexagon is going to be equal to everything on the bottom that is being reflected. So those are two lines of symmetry within that shape. In the second hexagon, you can do the same thing, vertical, same thing on the left and the right. You have one that looks kind of diagonal through the middle of these two line segments, and same thing over on this one. Then you can also go from vertice to vertice. So there's your horizontal, then from the top left to the bottom right corner, and from the top right to the bottom left corner. So there are 1, 2, 3, 4 different lines of symmetry through this hexagon. Sorry, 7. The last one, there's only one that you can draw completely horizontally. If you draw anything vertical, notice how this side is a little bit longer, and there's not going to be anything equal on that side of the line of symmetry. So now applying this to a real life situation, you're going to the store to buy some books, but your friend is going to buy some CDs. Where should you park to minimize the distance between both where you will walk? So you're trying to find the midpoint between point A and point B, which is another way to say that you're trying to find the line of reflection between those two so that they are equal between A and B. So you're going to reflect B in line M to get your B prime, or your new image of B. Then you're going to draw the line from A to your new image B. and it looks like that is intersecting at some point between your line of reflection M, and you're going to label that as coordinate point C. In order to get your C, you know that the distance of AB has to be halfway between your AC and your B prime C. Then you're going to do the exact same thing from your coordinate point B, knowing that those two things are going to be equal because they are being reflected over your line M. Those two lines are equal to each other. Then you have your substitution. You're plugging in BC into your B prime C. So the point that is the shortest distance between the music store and the reflected line of the books is your BC, or it is equal to your B prime C, so as to minimize the distance combined of AC plus BC that you both have to walk.